Hello everyone, welcome to video lecture on the concept of preemptive scheduling policies. In this video, we shall go through one of the basic type of preemptive scheduling policy, that is round robin scheduling with time slicing. First, let us go through the features of round robin scheduling with time slicing. Round robin policy aims at providing good response time to all the requests. So what is response time? Response time is the ratio of time since arrival plus service time of the process by service time of the process. So the time slice which is represented using delta is the largest amount of time that a request may use CPU when it is scheduled. For example, if delta, that is time slice, is one time unit, then each request can use CPU for one time unit when scheduled. Then it will be preempted. This preemption at the end of time slice is facilitated by kernel raising a timer interrupt once the time slice elapses. So every time when delta, that is time slice, elapses, kernel raises an timer interrupt. The round robin policy provides comparable services to all CPU bound processes, which results in approximately equal value of weighted turnaround times for all services. In round robin policy, the actual weighted turnaround time of a process depends on the number of processes in the system. That is, if the number of processes are more, then the weighted turnaround time will also be more. And if the number of processes are less, then the weighted turnaround time will also be less. The round robin policy does not result in a good system performance in terms of throughput, as it does not favor short processes. This drawback can be overcome by employing other preemptive scheduling policies, which we shall be discussing in future videos. Now let us try to understand round robin scheduling with time slicing better by considering an example. As you all can see, there are 5 processes or requests, namely P1, P2, P3, P4, P5, and their admission times are at 0, 3, 5, 6 and 8 time unit respectively. That is, process P1 will be loaded into memory at 0 time unit, P2 at 3 time unit, and P3 at 5 time unit, and P4 at 6 time unit, and process P5 at 8 time unit. Okay, and the service times are 4, 5, 5, 4 and 2 respectively. That is, process P1 requires totally 4 time units to complete its execution, while process P2 requires 5 time units to complete its execution. Process P3 also requires 5 time units to complete its execution, and P4 requires 4 time units, and process P5 requires only 2 time units to complete its execution. Let us schedule these 5 processes by following round robin scheduling with time slicing. By considering a time slice delta of 1 time unit, that is, the running process is preempted when time slice of 1 time unit elapses and that process is put at the end of the queue. Also, we are assuming that a new process that is admitted into the system at the same instance when a process was preempted will be entered into the queue before the preempted process. So, with this understanding, let us start scheduling these 5 processes. For this, let us consider a table wherein row 1 shows the time of scheduling and the next 5 rows shows the position of processes P1, P2, P3, P4 and P5 in the ready queue, and the last row shows the process which is selected or scheduled based on round robin scheduling policy. Simultaneously, let us also consider the timing diagram wherein on x-axis we have time units, and on y axis we have processes P1, P2, P3, P4 and P5. Now once let us look into the question. So this is the question, right? 5 processes P1, P2, P3, P4, P5 and their admission time 0, 3, 5, 6 and 8 time units and their service time 4, 5, 5, 4 and 2 time units respectively. So now at 0 time unit there is only one process in the ready queue, that is process P1, right? So there is no other processes for competing. So P1 will be selected for scheduling and P1 will be scheduled from 0 to 1 time unit. At 1 time unit again there is no other process in the ready queue, only P1 is available. So P1 will be selected for scheduling and P1 is scheduled again from 1 to 2 time units. Okay, at 2 time units again there is no other process in the ready queue, so there is only one process P1, so it will be in the first position and it will be selected again for scheduling from time unit 2 to 3. Okay, so now if you look into the question, at 3 time unit P2 enters, that is the admission time of P2 is 3, right? So now at 3 time units we are having two processes in the ready queue, process P1 and process P2. So P2 will be in the first position. The just now executed process P1 will be at the last, that is in the second position. So out of processes P1 and P2, P2 will be selected for scheduling and it will be scheduled from 3 time unit to 4 time unit. Okay, so at 4 time unit again there are only two processes P1 and P2. So P1 will be in the first position and P2 will be in the second position. So out of these two processes P1 and P2, P1 will be selected for scheduling and it will be scheduled from 4 to 5 units. So now if you look into the question, the service time of P1 is 4, right? So if you look here, P1 has been scheduled once, twice, thrice and 4 times. So P1 has completed its execution at 5th time unit, right? So now at 5th time unit, if you look into the question, P3 will be admitted. So at 5th time unit again we are having two processes, process P2 and process P3. So process P2 will be in the first position and newly arrived process P3 will be in the second position. So out of these two processes P2 and P3, P2 will be scheduled, right, and it will be executed from 5th to 6th time unit. Okay, so at 6th time unit if you look into the question, P4 is going to be admitted, right? P4 is having admission time at 6th time unit. So at 6th time unit we are having three processes, process P2, process P3 and process P4. So with P3 will be in the first position, P4 will be in the second position and just executed process P2 will be in the last, that is third position. So out of these three processes P2, P3 and P4, the process in the first position, that is P3 will be scheduled and it will be executed from 6 to 7 time units. So at 7 time units there will be only three processes, P2, P3 and P4 in the ready queue, wherein P4 will be in the first position, P2 will be in the second position and P3 will be in the last, that is third position. So out of these three processes P2, P3, P4, P4 will be selected for scheduling and it will be scheduled from 7 to 8 time units. So at 8 time units if you look into the question, P5 is having the admission time at 8. So P5 will be entering the ready queue. So we will be having totally 4 processes in the ready queue, P2, P3, P4 and P5 at 8 time unit. So with P2 at first position, P3 at second position, P5 at third position and just executed process P4 will be at last, that is fourth position. So out of these 4 processes P2, P3, P4 and P5, the process in the first position, that is P2, will be selected for scheduling and it will be executing from 8 to 9 time units. Okay, so at 9 time units again there are only 4 processes P2, P3, P4 and P5 in the ready queue, wherein P3 will be in the first position, P5 will be in the second position and P4 will be in the third position, and just executed process P2 will be in the last, that is fourth position. So P3 will be selected for execution and it will be executed from 9 to 10 time units. Okay, at 10 time units again there will be 4 processes P2, P3, P4, P5 with P5 at first position, P4 at second position, P2 at third position and P3 at last, that is fourth position. So P5 will be selected for scheduling and it will be executing from 10 to 11 time unit. At 11 time unit, so again there are 4 processes in the ready queue P2, P3, P4 and P5 with P4 in first position, P2 in second position, P3 in third position and P5 in fourth, that is last position. So now out of these 4, P4 will be selected for execution and it will be executed from 11 to 12 time units. At 12 time units, again there are 4 processes P2, P3, P4, P5 with P2 at first position, P3 at second position, P5 at third position and P4 at last, that is fourth position. So out of these 4, P2 will be selected for scheduling and it will be executed from 12 to 13 time units. At 13 time units, again there are 4 processes P2, P3, P4, P5 with P3 in the first position, P5 in the second position, P4 in the third position and P2 in the last, that is fourth position. So out of these 4, P3 will be selected for execution and it will be executed from 13 to 14 time units, right? So at 14 time units, again there are 4 processes with P5 in the first position, P4 in the second position, P2 in the third position and P3 in the last, that is fourth position. So P5 will be scheduled and it will be executing from 14 to 15 time units. Okay, so now if you look into the question, P5 is having a service time of 2. Okay, so if you look into here, P5 was scheduled once here, twice here. So it has completed 2 time units of execution. So P5 completes its execution at 15 time units. Okay, so at 15 time units, there will be only 3 processes in the ready queue. Process P2, P3 and P4 with P4 in first position, P2 in second position and P3 in last, that is third position. So out of these 3 processes, P4 will be selected for scheduling and it will be executing from 15 to 16 time units. Okay, so at 16 time units, there are 3 processes P2, P3, P4 with P2 at first position, P3 at second position and P4 at last, that is third position. So out of these 3 processes, P2 will be selected for scheduling and it will be executing from 16 to 17 time units. So now if you look at the question, P2 is having a service time of 5 time units. So now look here, P2 was scheduled once, twice, thrice, fourth time and finally fifth time. So P2 has completed 5 time units of execution and it has completed its execution at 17 time units. Okay, so at 17 time units, there are only 2 processes in the ready queue, P3 and P4 with P3 at first position and P4 at second position. So out of these 2, P3 will be selected for scheduling and it will be executing from 17 to 18 time units. Okay, so at 18 time units, again there are only 2 processes P3 and P4 with P4 at first position, P3 at second position. So P4 will be selected for scheduling and it is going to execute from 18 to 19 time units. So now if you look into the question, P4 is having a service time of 4 time units. So look here, P4 was scheduled once, twice, thrice and 4 times. So P4 has completed 4 time units of execution. So P4 completes its execution at 19th time unit. Okay, so at 19th time unit there is only one process in the ready queue, that is P3. So it will be selected for execution and it will be executing from 19 to 20 time units. So now if we look into the question, P3 is having a service time of 5 time units. So look here, P3 was scheduled once, twice, thrice, fourth time and finally fifth time. So P3 has completed its execution of 5 time units at 20 time units, right? So we can see that all the 5 processes P1, P2, P3, P4 and P5 I completed their execution at 20 time units, right? So we can say that all 5 processes complete their execution at 20 time units. Now let us consider one more table with 3 columns, wherein first column shows C, that is completion time of each process P1, P2, P3, P4 and P5, and second column TA, that is turnaround time for each process, that is P1, P2, P3, P4 and P5, and the third column W, which is nothing but weighted turnaround time for each process P1, P2, P3, P4 and P5. Okay, so now let us calculate completion time, turnaround time and weighted turnaround times for each of the process. So let us first evaluate completion time C for all the 5 processes. So as you can look from the timing diagram, P1 has completed its execution at 5 time units. So C of P1 is 5. And for process P2, P2 completed its execution at 17 time units. So C for P2 is 17. Process P3 completed its execution at 20 time units. So C for P3 is 20. And P4 has completed its execution at 19 time unit, right? So C for P4 is 19. And process P5 completed its execution at 15. So C for process P5 is 15. Okay, so this is how we calculate completion time for each processes. Now let's calculate turnaround time for all the processes, and this turnaround time is given by the sum of service time plus waiting time. Okay, so service time means when it was scheduled and waiting time means when it was in waiting state when other processes was scheduled. So for example, if you consider process P1, P1 was serviced for 4 time units and it was waiting for 1 time unit, right? So the turnaround time for the process P1 is 4 plus 1, that is service time plus waiting time. 4 plus 1 is 5 time units. Okay, so if we calculate for process P2, service time is 1, 2, 3, 4 and 5, and it was waiting for 1, 2, 3, 4, 5, 6, 7, 8, 9. So service time is 5 time units and waiting time is 9 time units for process P2. So 5 plus 9 is 14 time units. So now the turnaround time for process P3. Process P3 was loaded into memory, or it was admitted at 5 time unit, but it was scheduled at 6 time unit, right? So it was waiting for 1 time, then serviced, again waiting for 2 time units, again serviced, then waiting for 3, then serviced, then waiting for 3 time units, then again serviced, then waiting for 1 time unit and again serviced. So service time is 1, 2, 3, 4, 5. Waiting time is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So 10 plus 5 is 15 time units. That is the turnaround time for process P3. For process P4, P4 entered the queue at 6 time unit and it was scheduled at 7 time units. So it was waiting here, 1 time unit waiting, then serviced, then 3 time units waiting, then serviced, then again 3 time units waiting and serviced, 2 time units waiting and then serviced. So totally 4 service time units, and then waiting time is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 time units of waiting plus 4 time units of servicing is 13 time units. So the turnaround time for P4 is 13 time units. So for P5, P5 entered at 8 time unit, but it was waiting for 2 time units, right? So it was serviced for 2 time units, but it was waiting for 1, 2, 3, 4 and 5. So 5 time units of waiting, 2 time units of servicing. So 5 plus 2 or 2 plus 5 is 7 time units. That is the turnaround time for process P5. Okay. So this is how we are going to calculate turnaround time for P1, P2, P3, P4 and P5. Okay. So now weighted turnaround time. So what is weighted turnaround time means? Weighted turnaround time for any process is given by the ratio of turnaround time by service time. For TA, sorry. So for P1, turnaround time is 5, service time is 1, 2, 3, 4. So 5 by 4 is 1.25. For process P2, turnaround time is 14 and 14 by, what is the service time? 1, 2, 3, 4, 5. So 14 by 5 is 2.8. For process P3, turnaround time is 15, which we already calculated, and the service time is 1, 2, 3, 4 and 5. So 15 by 5 is 3.0. And for process P4, turnaround time is 13 and service time is 1, 2, 3, 4. So 13 by 4 is 3.25. And for process P5, turnaround time is 7, service time is 2. So 7 by 2 is 3.5. Okay. So this is how we are going to calculate the completion time, turnaround time and weighted turnaround time for each processes. Okay. So then we are having two more components, that is TA bar and W bar. What is TA bar means? It is average turnaround time, and what is W bar means? It is average weighted turnaround time. Okay. So TA bar, that is average turnaround time, is given by sum of all this 5 turnaround time divided by 5. That is, we have to take the average of turnaround time. So 5 plus 14 plus 15 plus 13 plus 7, which is equal to 54, divided by 5 will give you 10.8 time units. Okay. So similarly, for weighted turnaround time or average weighted turnaround time, we need to sum all these 5 weighted turnaround times divided by 5. That is 1.25 plus 2.8 plus 3.0 plus 3.25 plus 3.5, which is nothing but 13.8 time units divided by 5 will give you 2.76 time units. Okay. So this is how we are going to schedule any given processes using round robin scheduling with time slice and calculate their completion time, turnaround time, weighted turnaround time, average turnaround time and average weighted turnaround time. So that's it for this video. Thanks for watching. I hope you all got a better idea about round robin scheduling with time slice. If you feel worth sharing, do like and share more. Meet you all soon with a new video. Until then, take care and goodbye.